Welcome back, everyone, to the third episode of Season 2 of Across the Opti-Verse. Today, we've got our in-house data science expert who's going to talk a lot of things around AI and the kind of cross-industry applications it has. He holds a doctorate in data science. He lives and breathes AI, data science, anything around those fields. And he's really passionate, and when we were discussing the episode and talking about how AI is shaping our world. Before I start rambling on, Toby, welcome. Maybe you can give a chance to introduce yourself.
Thank you very much, Dean. And I am Afolabi Oluwatobi Joshua, a senior data science consultant with Optimum. So data science, I actually have my background in electronics engineering. Actually, my first degrees, masters, and PhD were all in that field. But I kind of moved into data science around 2015, that time, where I had to work on a computer vision task. And since then, it has been data science all the way. So I have expertise in your traditional machine learning, deep learning, large language models, and all of those stuff. Yeah, reinforcement learning and anything data science. Thank you.
Fantastic. Yeah, so thank you so much for making the time to be with us today. We really appreciate it. It's a cool episode, and we hope you guys enjoy.
Good.
Okay, Toby, let's talk. Let's set the scene. When we kind of discussed this episode a while back, we were talking about the big picture, and you mentioned something that kind of stuck with me. AI is a dynamic field.
Yeah.
Let's talk about that. I mean, how dynamic is the field of AI, and from your perspective, what drives this kind of rapid evolution?
Thank you very much, Dean. Yeah. So what we call AI today, many people think AI started maybe 10 years ago. AI. No, that's not actually true. AI started as far back as 250 BC when a Greek inventor called Ctesibus, actually Ctesibus of Alexandria, if I'm correct, he invented something, a self-regulatory system, or he called it the water clock. Okay, and that was actually the first use of AI. Wow. in as far back as 250 BC. What he invented was that he made reading the time to be much more accurate, and it was used for 1,800 years before we had another invention. So it started as far back as 250 BC. In fact, the name AI was invented as far back as 1956. Okay, and so it has been there for a long time. It has been there for a long time. So and actually, after 1956, around your 1957 up until 1976, there were inventions. In fact, people had a lot of hope or belief in AI, and enthusiasts were promising government, big organization, a lot of things. The things we see today, they were promising the government and all of that. But because of some hindrances, which would be computing power, which would be availability of data, they could not deliver. And governments, public organizations got discouraged. And actually, in 1976, the British government stopped funding AI. And that was the beginning of what we call the AI winter, where everything just died down. Because, again, they could not produce at a large scale what was promised. Okay. So, but around 2001, we started seeing the resurgence of AI. Take note, as at that time, we already have Google, we already have people already used internet. So the problem of data was already being solved. Yeah. Okay, so data was now available. People were posting stuff. People were asking questions. So we now have data. And also around that time, we started having the evolution of computing power. We now have your laptops. We now have GPU as against CPU. Around that time, we also have development in software. We now have TensorFlow, things that can actually help the build up of AI. And that was when AI started picking up again. So we had stuff like your ImageNet. Google started trying the driverless cars. We developed algorithm that was better than human, especially in playing Argo, in playing chess. And that was the rebirth of AI. And that's what we now have today. So what fueled what is called AI today, like I said, didn't start today, but what fueled the explosion, the boom that we have today is number one, availability of data. Number two, improvement in hardware, like your GPU instead of CPU. We have super fast computing power now. We have supercomputers. And then number three is improvement in software. We also have your TensorFlow architecture. All of these were not in full place as at then. So that's what we have today as the AI boom.
Yeah. So essentially, you're saying, I mean, the way I got it, the people, generations before us would be, was their dream, the access.
Exactly.
And we've got access now. We now need to start using it.
Exactly.
I mean, that's incredible, and it's awesome to see your passion and your knowledge of the history of AI. Didn't know about that, the water clock. So that's really, really cool. I know we're going to talk into the industry application, and I know today we want to focus on finance. I've got a lot of questions for you around the finance insurance fields, but I want to start. You did a project. Your PhD was around computer vision, as you've already mentioned.
Yes.
Let's just talk about that quickly.
Okay.
Yeah.
So, the PhD was about a very popular eye disease called glaucoma. Actually, glaucoma is the second cause of blindness in Africa, globally, second only to diabetic retinopathy. So the reason for this is because people with the disease don't even know they have the disease until blindness starts to set in. So they call it the silent thief of sight, because you can carry it and you don't even notice. It doesn't give you a headache, nothing. Everything looks normal. So previously, or to detect glaucoma, you need to go through about 5 different tests, like your high pressure, like eyesight, and it takes a whole lot of time. They have to check you over a period of time. And again, we have few experts, especially places where you don't have direct access to doctors. So that was the problem. So we thought about, or I thought about, can we have an algorithm, a computer vision algorithm that takes the image of the eye and then detect the presence or absence of glaucoma within seconds. So 2 things that will really help to deter the blindness that we have, the rate of blindness that we have, because now if you can detect it early, you can actually stop it. That's the good thing about it. The moment you detect it early, there are medicine that you can take and then to stop it, or you can manage it. So that's number one. Then number two, it also frees up the ophthalmologist because it becomes like a guide. Okay, instead of going through the 5 tests, they can know ahead of time what to expect. Okay, the model is saying glaucoma is present, so likely there's glaucoma, but again, it's not a substitute to the test, but it's like a guide to help to, and that was a very good success. The model was designed, and then it had about 98% accuracy.
Wow.
So which is quite impressive. So yeah, that's what
cool. I mean, that's exactly it. Particularly in continents like Africa, we know South Africa alone struggles with access to that. We have the specialists, but the access to it is what causes it. And there's only so many doctors. So you, with your model, like something you created, not just for glaucoma, for any disease, if you can already kind of with your model say no, it's not glaucoma, then they're actually seeing the people. That's brilliant. I mean, that's amazing. And 98% success
accuracy.
Wow. And how long did it take you to develop that?
It took me 2 years of hard work.
2 hard work, yeah, I'm sure.
2 years of hard work. And 2 years, I'll count myself a little bit fortunate, because when you're solving a problem like this, your biggest challenge will be data, access to data. But I used publicly available databases because there are some people that have already done the work, collected the database for you so that you can use. So that really helped me to shorten the time taken. But even with that, it took me about 2 years, because I can't count. I must have reiterated the model more than 300 times.
Really?
Just changing something, trying to get the best out of it. Yeah. So
I mean, but 2 years of work for so many people to benefit from. I think that's incredible. And
thank you.
Amazing. Well done.
Thank you.
Okay, we've spoken about your PhD. As I mentioned, let's go into finance.
Okay.
I know at Optimum you've worked a lot in the finance industry.
Yes.
Let's talk maybe how have you seen AI being used in these finance projects?
So AI cuts across every human endeavor. Every. I struggle to think of any human occupation or endeavor where AI has not encroached or impacted. So in finance, so we use AI actually. Number one is to detect fraud, which is very, very important. When it comes to finance, you can't take away fraud away from finance.
Yes, yes.
So we use machine learning algorithm to detect AI to detect fraud, and there are models that do that before, but now we are able to do it much more accurately.
Yeah.
And the good part of it is we can actually catch it in real time, right now, in real time. As the fraud is going on, you can get the alert, not a week after or 2 weeks after. It can be caught in real time. So that's number one. Then number two, in credit risk, when you want to assess the risk of some, especially when it comes to loans and all of that. Traditionally, there are models that do that, but of course, that takes a while. But now we have models that do that using AI. But the good part of AI is that we can now inculcate other things like your social behavior. We can now use your social media platform to even check your credit rating, or to see how your risk, to measure your risk, like your Instagram page, like your Facebook page. Recently, America announced now that if you want to get visa, they also need to check your Instagram page, Facebook page. It's because to assess the totality of a man, you also need to have an idea of his social behavior.
Yeah, sure.
So now we have the ability to inculcate that into the models, and yeah, so many applications. So those are just the few that time will allow me to talk about.
Yeah. Time is obviously our biggest constraint here.
Yeah.
I mean, as you said, there's a data boom. Obviously, ethically using the data correctly, but businesses can use the data to protect themselves and to protect their clients, to ensure that they're getting what they need, and the business is making sure no one steals from them.
That's true.
I mean, and yes, I know that's a very big simplification on my part.
Yeah.
I want to then talk about the project you're working. Obviously, we can't mention names, but you're working with a major player in the financial sector.
Okay.
And you worked on collection models, you mentioned.
Yeah.
Maybe just as one of the kind of many things of AI, can you tell us about what the work you did there?
So collection. Okay, let me give a background. So when loans are given out, okay, so it's easy to dish out loans.
Yes.
The difficult part is when you now need to collect, the loans and collect the payment and all of that. So the idea is that, can we use AI to predict, given the risk of this person, given the amount he has been given, given his history, okay, can we predict how much we'll be able to get from this person? So now, as an institution, we are not just looking at one person, we are looking at everybody that we're giving loan to. So the good thing about the model is that now we want to put in things like your public holidays, because, you like it or not, public holidays will affect the collection behavior. Okay, I don't want somebody calling me for me to pay my loan on a public holiday. I'm enjoying a good time with my family.
Yes.
People can take it off as, Kai, this is a public holiday, why are you calling me? So public holidays, weekends. Okay, so the demographic that the client is, okay, the country, is very sensitive to weekends. Weekends are days where I just want to enjoy myself. Nobody should call me. I know I'm owing you, but please don't call me on weekends.
Exactly.
Weekends are for me.
Yes.
So we want to put in all of those things into the model. So your weekend, your public holidays, strike actions, downtime, system downtime. So we want a model that can put in all of that, and also together with the history of the loan taker, if there's anything like that, can we now predict how much to collect per day for the month, every day for the month. So that was what the model was about. Okay, so to be a bit technical, I used a bit of the traditional machine learning, but a lot of feature engineering. Feature engineering is to make sure that the features that I'm using are actually are useful for what I intend to get out of the model. So a lot of feature engineering, and I just use the traditional extreme gradient boost model, but together with other foreknowledge, history, credit rating, and all of those things.
Well, I think you broach an important point in AI. Now, my experience in AI is quite limited. But it's even just general data science.
Yes.
You can't use these things independently.
Sure.
Great,
sure.
you've got this perfect AI model that fits your data. But do you understand the geographic location of where this data comes from?
Exactly.
The people that are working with the product. It's not just finance, it's anything, retail, telecommunications, healthcare. Do you understand the sensitivity of your data set as well?
Yeah.
And as you say, feature engineering really important because you can have, 800 different variables about 1,000 people on your product, but only 5 of them really truly give you an understanding, let's say, of their credit risk, of their potential to default, of their ability to take up a new product. That's really good, and it talks to that personalization. Not only are you personalizing the data and the solution, but you're personalizing the solution to the client.
So let me give you a real life example. I was talking about personalization and understanding the data. About 15 years ago, when face recognition, the use of face recognition to lock your phone or to unlock your phone, when it first started, a friend of mine bought a phone. It was really, really new. This is about 10, 15 years ago. It was a new technology. He bought a phone. And one of the features of the phone is that you can lock the phone with your facial recognition, with your face.
Yeah.
But what happened was that he could lock his phone, but unfortunately, his younger brother can take the phone and unlock the phone.
Yes.
Okay, not just his younger brother. He brought the phone to his friends, and a few of his friends can actually unlock the phone. And then there was a question that, okay, this is supposed to protect my phone.
Yes.
What's the problem? Why is it that everybody can unlock my phone?
Yeah.
And he was not the only one that experienced that. A lot of people experienced that. So what we found out was that when the model was trained with pictures, mostly not from Africa, but from, of course, it was developed in North America, in US, in Europe. So the model was able to recognize faces like that, features peculiar to the Northern Hemisphere, okay? US, Europe, very good at that. But when you bring it down to Africa, it couldn't distinguish between my face and my brother's face because we have very strong similar features. Exactly. So it failed. It failed. So, but now it has been corrected. So now, and that brings back to the question of where we want to use the data. What's the demographic?
Yes.
Okay. How do we make sure that everybody is included?
Yes. It's that macro geographic element.
Exactly.
And as you say, the intention when they were developing it in North America, Europe, they had access to their data. Then I think it also talks to just any AI solution. Yes. First solution is not the right solution.
Exactly.
First solution is going to tell you what's wrong with the data. Second solution iterates. And it's with AI, with any project, iterative approaches provide the best results. And that's really actually, I didn't actually know about that. So that's great to know. I think we are short on time.
Yeah.
But I also want to talk around, as you've mentioned, personalization and even predictive analytics to ensure that you get the right results. Personalization is something that comes up across industry.
Yes.
How do we get the right offer? We've got this rich data set. How do we get the right offer to the right person at the right time? Good. And how do we even know what the right person is? How do we ensure we don't segment our data to say we've got 1,000 different people types? That's not a solution. But also we don't say, oh no, we've got 2 types of customers. So let's just, maybe if you can, I see it a lot in my retail and banking kind of applications. They're always saying, we've got the perfect offer for you. What does personalization of data actually mean?
So that question is a question that every company will love to have a perfect answer to. Yeah. Perfect answer. But again, it's a work in progress. So personalization is when you have a custom-made offer that suits your need, okay? So the way it's being done currently is, again, we have data about your historical behavior, your pattern, for instance, finance, the way you spend, okay? Your bank will have a little bit information about your salary, how much you spend out of your salary. If it's someone that is always spending more than his salary per month,
yes,
they know that, okay, this is a very good person to give this offer, to maybe this loan offer, okay, yes, something just to buffer your salary. So they look at your history, okay, your behavior, okay, and then they compare that with, there's something called segmentation. They try to put people with similar behavior in the same group,
yes,
and then offer them products that they think can benefit them. This has got two sides. Number one, if you get it right, then that's perfect. If you get it right, that's perfect. Then number two is the fact that human human beings are dynamic also.
Yeah.
Okay, what fits me 2 months ago may not fit me. In fact, what fitted me yesterday may not fit me today because things change. And that's one of the challenges when it comes to is it personalization?
Yeah.
Okay, because it is a fast changing thing. You have to keep. It's expensive, and it for a lot of industries like a try and error. Okay, let's try this. Let's measure the effect. Oh, not exactly what we want. Okay, let's try that again. But yes, it's a very good field. If we can get a very good handle of it, it's something that can lead to a very good profit from the side of the industry, and it makes the client happy.
Yes,
because
definitely.
you are giving me exactly what I need.
Yeah.
Another example is telecommunication.
Yes.
When they offer you maybe 5 megabytes extra data for someone that has fiber in his house.
Yeah.
I'm like, okay, you are just wasting my time.
Exactly.
Okay, so those are the challenges.
Yeah, and I mean, I really like what you mentioned. What happens yesterday is not what's going to happen today. So as you handle it, and that comes to using your personalization or your AI or your machine learning or just basic data science responsibly, but also you have to be dedicated to it in the long term.
Exactly.
Because you cannot design an algorithm and expect it to work next week.
Exactly.
You have to continuously tweak, monitor.
Yes.
You know, that's a brilliant. And I think that's all raising kind of to my last question, the crescendo, if you asked. There's always an ethical question around responsible use of data in AI. How do you personally ensure that you're using it properly and it doesn't cross to unfairness bounds or, you know, reaching into someone's personal life?
So the topic of AI ethics is a big topic on its own. It's as big as AI itself.
Yeah.
In fact, developed organizations have an entire faculty or department dedicated to that. Because AI comes with a lot of questions. Okay, a lot of questions. Ethics, like you raised. Okay, fairness is under a framework called justice.
Yes.
Justice. How do we ensure that AI is actually fair? AI is actually treating everybody equal. That question is still being answered today.
Yes.
There's no, because again, we are dealing with human beings. What is fair? What I think is fair let me take this. South Africa may think this is fair, but you travel to somewhere like China. China thinks, no, this is not fair.
Yeah.
We don't think this is fair. China thinks this is fair, and South Africa says, no, this is against our culture, our society, and our ethics. So it's now very difficult to make a generalized framework on what is fair, okay, what is not fair, what is bias, what is not bias, okay, what is beneficial. You know, there's another framework called beneficence. In beneficence, you want to make sure that AI benefits humans. Okay. Another country says, no, we don't just want AI that benefits humans. We want AI that benefits any living thing. Okay. Sure. Another country says, okay, we don't care about the plants. We just look at humans. Yeah. Does it benefit humans? So it now becomes difficult to have a generalized framework. And that is still an ongoing work. And I believe it's going to take a while before we reach a consensus as to what is actually bias accepted globally and what is not biased accepted globally. So the way forward is each organization, each country will have to sit down, stakeholders, users, governments, policymakers. We need to sit down and say, okay, for our society, what do we want? Yeah. Okay, what do we want from AI? And that's why Africa needs to get involved in AI, because we can't wait for people from the Northern Hemisphere, America, to make decisions, because they will make decisions tailored to their society, which may not be acceptable in our society.
Exactly. Yeah, I think that's a brilliant way to close it off. And as you say, we are, one of many kind of institutions in Southern Africa, but in Africa alone, working to do that. You work in projects, and it's not just in kind projects, it's in personal projects. And I see it a lot through the staff at Optimum. Toby, thank you so much.
Thank you for having me.
I know there's some things in the work. Hopefully we'll see soon some potential kind of presentations and webinars from you. So please look out for that.
Thank you.
But obviously we will, as Optimum, be sharing those invites with you.
Thank you.
We've covered a lot today, and I just want to say thank you. It's great to see your passion and your knowledge in this field, and we really appreciate it.
Thank you.
As always, you guys can catch us wherever you get your podcasts. That's us for now, and we look forward to seeing you next month. Cheers.
Bye.
Toby, thank you very much.
You're welcome.
Appreciate it.